Okay, let's look at what are exceptions. Now this is a small piece of code in which it's doing a division operation. So we have a variable called as x. We are taking an input variable called div and performing a simple operation y is equal to 10 by div. Now in this division operation, we all know that any number divided by 0 is undefined. So we should not be actually dividing a number by 0. It's an arithmetic rule. You can't, anything divided by 0 is not a defined number. So if I enter a 0 here and I have not verified before division that is this number 0 or not, it is going to throw an error which is called as an exception. Exception is are errors which occur at runtime when the code is running. During that time, if some exceptions occur. Now, for example, if I remove a semicolon here, this is a compile time error. It is pointing to me that there's a problem before I'm executing the code. So this is a compile time error. Now, exception are runtime errors, which are thrown or which occur when the code is running. Fine. So under this, there are two categories. One is basically exceptions in Java Commander section called as throwable. So we'll not go into too much of detail of that, but just as a introduction, there's something called as throwable class or throwable category under which you will have exceptions and you have errors. Okay. Now, exceptions are something which can be defined, which are known that it can occur. For example, here we know that divide by 0 can occur. So we know how to handle it and what to do for it. Errors are some things which are not defined and they are things that occur randomly which we might or might not expect to happen and how these are handled uh, we are not going to cover right now. We are going to look at only how exceptions are handled. Right? So let's look at what happens when we don't do anything. So in this code, we are simply doing the division. We are not trying to handle it in any special way. So let me run this code. So I enter the number 0 here for this div and I say enter. It tries to divide and it comes up with an exception. In it tells you which program or which function the exception was thrown from. It gives you a name of the exception. This is a built-in name that this is an arithmetic exception and it tells you what happened because of which the exception came. So it is saying you have divided by 0. Because of that, this exception came and it also tells you on which line in this function was the exception occurring. Right, so this is the 10th line where it came across this exception. So this is something called as a stack trace or trace of functions during which the exception occurred. So if you have a more complicated code, you will see a much more longer series of function calls to show you how it reached that exception code. But this is a simple code, so you only see two lines of this. Now, there are multiple problems in this. Now, one is this error that we see here is very programmatic error. It's something technical people can understand. For a non-technical person, this might not really make any sense. He may he like, what is this set of instruction that is being thrown at me? Second, we might not want to end the program like this. We might want to handle it in a more graceful manner where we say, okay, this went wrong. Let's try to correct it and try to go back and take the input again. Right? So, any such situations where things can go wrong while executing and you want to handle it in a proper way can be done using exceptions. Okay. So in this case, maybe you can put a if condition. If divide equal to 0, then give pop up a message saying this please do not enter a 0. That is one way of doing it, but that cannot be done for all cases and all type of problems cannot be handled just by an if condition. And second, that is not a very you can say a graceful way of doing it, because maybe uh, divide by zero is not something that you expect to happen, or you want to have a better way of trying to handle it. So exceptions give you a much more graceful way of handling how runtime errors can be taken care of. Fine. So in Java, the exceptions are handled by a try catch block. Fine. So what is a try catch block? Now, whenever I have a piece of code in which I expect something to go wrong, so we are not sure things will go wrong. If, for example, if I'm running the same code and I just enter a proper number, I enter 2. There's nothing wrong with this. It did 10 by 2 assigned to y and the code exited. So there was no error in this. But there can be an error if we enter 0. Okay. So whenever there's a piece of code in which you expect something to go wrong, you can put that piece of code into a block called as try block. That is, you're saying try this piece of code. Maybe you might get an error, maybe you might not get an error. So we are not sure. Try it. Try executing this. If it executes successfully, no problem. If it does not execute successfully, while executing it, if something goes wrong, we will handle it. Okay. So that is what a try block is all about. So how do you define a try block? So the same function, I have started the try keyword, open a flower bracket, close flower bracket. Inside this, I have put the same set of instructions. Int x is equal to 10, take the scanner input, take an input number div and do the divide operation. So the program did not change, it remained the same, but I have put it into a try block, meaning I expect that during execution of this code, maybe something might go wrong. Right? So just to make sure that I don't miss that error, I have put this into a try block. Now, if something goes wrong, what are we supposed to do? Okay, so we have to have a way of handling it. So when you're saying you're trying something, if something does go wrong, what are you going to do for it? So that is where the catch block comes into picture. So the catch block is a combination with try. So every try block has to have at least one catch block, which says if in the try sequence something does go wrong, what do we do? So whatever exception happens, that has to be caught. So that is the catch block. So catch the exception, and you're mentioning what could be the exception. So here it is arithmetic exception. So we are saying we expect an arithmetic exception to come, and we're giving it a name E. And inside this, I can print a more easily understandable type of error, which any user can understand. Okay. So here we are printing do not enter 0, which anybody who sees who enters this number for that input will see and understand, okay, I entered 0, that's why something went wrong. So it is easy to understand compared to what we saw in the previous case where it was giving a long sequence of instructions and the stack trace. This is slightly better way of looking at it, right? So so try and catch are a combination. So you put the problematic or expected error part of the code in try block, follow it immediately by a catch block, give what exception you expect to happen, and print whatever message you want to print. Anything you want to do, it can be a message printing, you might do something else, anything that you feel is right for your exception, right? So let me execute this and see what is the output. So let me enter a 0 now. And see, the error is much simpler now. It simply said do not enter 0. So as compared to what we saw in the previous program where we did not handle the exception, we are seeing a much more easier to understand error. So that's a try catch block to make sure we can handle the exception. All right. Right. So that is the basic logic of exception. So you have a piece of code which might go wrong, and you're doing putting it in a try block, and you're catching it by a catch statement. Okay. Now here the program exited after printing the statement. You might want it to continue execution, so that is also possible. That is, after throwing the exception, you might say, okay, take the next set of input. So what we have done here is we have taken a flag called input. We are verifying if input is not equal to 1, and we put the same piece of code uh, into try. Now what you have to see is, let me just go back to the previous code. Let's see. Now here, after this line of code, nothing gets executed. So within the try block, if I put, if exception happens at this line, it is going to stop executing here and directly jump to here. Right? So this line is not going to be executed. If this line did get executed, that means there was no exception here. Right? So let me just run this and show it to you. So you can see it did not uh, print this, right? So it executed this. There was an exception. It stopped here, came to catch, executed this, and the program got finished. Right? So that is the case of exception. If there was no exception, it would have come to this line, right? It would have executed the second line also. So for example, if I do a proper division, it executed this and it executed this. It will not execute catch anymore because there was no exception here. So it will execute this and end the program here. So there is no catch required because there was no exception, no catch is required. So if you want to make sure that after the catch you reattempt the taking the input, okay, so you can put this into a loop and ask it to continue taking the input. Ask it to, okay, you did something wrong once, let's try to take the input once more. So that's what we're trying to do here. So while input is not equal to 1, where input initially was 0, we start a try block, do the same operation. Now if we come to this line, it indicates that we did execute this successfully without exception. So there is no problem, no exception raised. So we can make input is equal to 1. It will try to go back here. Input will be 1. It will exit it. But if this did not get executed and this try catch is inside a loop, so after printing this catch, it will go back to this while loop, right? And it will see that because input is still 0, because we would not have executed this, input is still 0. So it will again come in and take the input, right? So let me just try to execute this. So if I enter a 0, it will throw the error, do not enter 0, because it tried to do this division, it encountered an error, it printed this and went back to my uh, while statement. Input is not equal to 1, again come back here, again do a try operation, try block and try to do this. So it will again take an input. If I enter 0 again, it will again keep looping this till I don't enter a value which will divide this properly. So if I enter 2, sorry, if I enter 2 here, that is okay. So as soon as it did the proper division, it set the input and it exited this. So I can keep looping this and till I am able to get the right input. Right? So the catch statement need not be end of the program. You can reattempt the try block by putting a loop scenario like this. Alright, so now each try block can be associated with multiple catch statements. So after this, I can have another catch. Okay, so maybe I might have something like a null pointer exception. where I'm trying to refer to an object which I have not created yet. Fine, so that could be another problem. So maybe I'll say object not created. Anything. So any exceptions which are supported under Java can be put under this catch, but it goes in a sequence. So when it exception happens, whichever is the first matching exception, it will pick that up. All right. So some exceptions sometimes might be matching to multiple catch statements. It is possible. Whichever is the first matching exception, it will take that up and execute it. All right. So I can have any number of catch statements, but a catch statement by itself cannot exist. It has to be followed by after a try block only. You can't have a catch statement independently without having a try block. Right. So that's the try catch block. Now, in case I want, as a programmer, you would want to throw an exception with a very specific error, a specific message. So, for example, here I'm doing the same thing. I'm taking an input here. I'm verifying a divide is equal to 0. And if it is 0, instead of letting the system throw the exception, as a programmer, you are throwing the exception here. So, throw a new arithmetic exception with this error message. Okay, so I can say maybe invalid divide by 0, some more logically correct exception which a user can understand. All right, so when I throw this, it is still arithmetic exception, so it will be caught here with e being equal to whatever message you have sent here. Okay, so that's a throw keyword. If you want to throw an exception in any part of the code try block, you can throw it, throw new that exception name. There are a number of exceptions that Java supports. We'll see a list of those exceptions. That exception, if you want to customize the message, you can give a custom message here. Receive that exception in catch, and you can print out that custom message here. Okay. So if I execute this now, so I'll again enter a 0 and it will immediately give me it was an arithmetic exception with this message, which was the message that we sent across as part of the throw keyword. Okay, so throw is a keyword which allows us to throw exceptions in the program. So in the previous cases, the exceptions were being thrown by the compiler itself while it was executing. While the program was being executed, invalid operation happened and automatically an exception was thrown, which was caught by us in the catch statement, and we did some operation. Here, the throw of the exception is done by the programmer itself. So I can say throw a new exception of the type this with this as the exception message. So it is being caught here, and I can say, oh, this E will be equal to whatever message you are sending from as part of the exception, right? So that is a throw part of the exception. So you can have any number of throws you want in your program. Now, if a method or a function is throwing an exception. So for example, here I have a class in which I have a function called as divide, div, performing the same operation what you have done before. Int y is equal to div 10 by div. Uh, okay, that's okay. Fine. So here I am throwing this arithmetic exception, but you can see that this function does not have a try catch block. That is, even though I am throwing an exception here, there is nobody catching this, right? So I can do the catch from wherever this function is being called. So I am calling this function inside main. So in main, I am calling divide. This divide is being surrounded by a try catch block, right? And here I am saying this divide might throw an arithmetic exception. Now, if here, uh, as a person who's implementing this main part, I can see the div and figure out that okay, I this is throwing an arithmetic exception, so I can use the catch statement for arithmetic exception. Now the programs become bigger and you're using a method which is written by somebody else. You might not know that which exception this method might throw. Right? So while defining the method, you can mention here that this div method might throw an arithmetic exception. So throws does not mean it will always throw. It can or it cannot, depending on the circumstances. This function may throw an exception of type arithmetic. So wherever we are calling this function, we can surround it by a try catch block and receive that or catch that SMS, catch that exception and handle it as we want to handle it. Right? Now, if you do not handle an exception, now here if I let's say remove the catch block, so let's say I don't have a, okay, now there is nobody handling this exception. I'm throwing the exception, but neither is this a try block here, nor is a try block here. So what happens now is the Java handles the exception by default within itself. So it uh, handles the normal exception like it would do at any given point of time. When there was no try catch block, it will handle the exception by itself. So it receives the SMS, it receives the exception, and it will print out the normal set of messages that as a compiler it is supposed to throw. Fine. So that is in case you don't have a try catch block. But it's always recommended that you handle this exceptions that you're throwing yourself because you are doing a very custom exception throw, so you know how to handle it better. So generally it would be recommended that if you are throwing the exception, you catch it and you handle it however you want to handle it. And this obviously is not a very understandable error, right? So for a non-programmer, this error seems too complicated. It's like, what is this trying to tell me? Code breakpoint, this line, so many lines are being shown. So it is always better to give an error which the user can understand easily. So you can do a catch and then print whatever is logical or easily understandable way of handling the exception. Right? Now, there are a number of exceptions that Java has. This is a list of possible exceptions, arithmetic exception, array index out of bound exception. If you try to access the array uh, index, which is not like if you create an array of five numbers and you try to access array of sixth element or seventh element, you're trying to access elements of the array which are not part of the array. So it's out of bound. There's illegal argument, illegal state, thread related exceptions, null pointer exception. So many things are possible. Okay, these are not the only list. There are more exceptions, but this is quite almost most of them. Okay, and these are built in, so the names are fixed. You can create your own exceptions also in Java, which probably will cover in the next video. But these set of exceptions generally are more than enough to support the basic set of programs that we would want to write. Right? So that is basics of exception. So please execute these set of codes to understand better how things work. Yeah, this one final concept, finally. Okay, so there is a keyword called as finally. Now, what this does is after this try block, okay, now irrespective of did we throw an exception or did we not throw an exception, maybe there is something we want to do as part of the program. Okay, so maybe there is exception, so we handle it here. Maybe there is no exception, we finish the normal division. In either case, we want to give a message to the user that okay, our operation is finished. So this message should be displayed irrespective of there was an exception or there was not an exception. Right? So if I put this message here inside this, that means this is going to be printed only if I execute this. properly without exception. If I print it inside this, inside the catch statement, this is going to be executed only if there's an exception and we come to the catch block. So this will not be independent of exception being there or not being there. So when you have a part of the code which you want to execute, irrespective of exception being thrown or not being thrown, we can use the keyword finally. So you have a try block followed by a catch block, any number of catch blocks. At the end, you will have the keyword finally. Okay. So the finally part of the code or block of the code is executed irrespective of exception being thrown or not. So if I execute this now, if I enter a zero, I will have an exception saying do not enter zero. It will execute this line saying the program finished. If I enter a proper value, which was normal division, so that there is no divide by zero, then also it will execute finished, which was this part of the line. So finally is saying, okay, you tried something, it worked without exception, all right. It worked with exception, then also okay. We'll still continue to do this part of the operation. Right? So finally is a block of code which has to be executed irrespective of there was an exception in the try block or there was no exception in the try block. But remember, finally has to come at the end after all the catch blocks. Fine. So that because you try to handle all the possible exceptions first. If none of the exceptions are there, does not matter. That means there's no exceptions. You still execute the finally block of the code and then only exit the part. So this is optional. I need not always have it. I can remove it. The code will still work, not a problem. But you need to have a catch block. If you have a try block, you can't leave the catch block out. You can leave the finally block. Finally is not mandatory, but you need to have the catch block always. Finally block is optional. Catch block is mandatory. Alright, that's about in exceptions. So we'll be sharing all these codes, interfaces, packets, and exceptions in the GitHub. Please download them, test them yourself, and modify it and see if it works for you. Thank you.